Edouard is an architect with the Institute for Advanced Architecture of Catalonia, and in his architectural practice, Edouard is dealing with topics of sustainability and climate change. Among other projects, his team has managed to successfully 3D print a building using soil, using earth. For that, they became the winners of the new European Bauhaus prize for this project. So we're very happy to hear from you today, Edouard, about this intersection of design, architecture, and sustainability transitions. Okay, so with that, Edouard, I'll let you start your presentation.
Super. Thank you so much. Thanks a lot for the invite and for the opportunity. As you mentioned, I'm going to talk here about work that has been done by, I think we've been over 100 people involved in the project over the years. So you see me, but you have to see behind a lot of researchers, students, and experts from many different fields. I'm going to share my screen. Yes, 3D printing with soil, right? Very kind of contemporary or modern or new technology in the field of construction potentially, and then a material that has been around for forever. And we've been for now, I think it's the 9th year that we are investigating the possibility of this technique to go towards building, to go towards a new architecture, and to go towards living. I think I want to ground a little bit, why is earth such a good material? It's an extremely good material because, first of all, it's been used since thousands of years in the construction world. It's a material that is available in most places. There are a few countries or few maybe regions rather than countries where there is little earth. But in most of the places under our feet, we have actually a building material available that is also potentially for free, right? At the moment in the construction sector, when a building is made, earth gets excavated, and normally trucks take it 50 kilometers, 100 kilometers away from the city, and it normally forms trash. No, that's why this material is actually available. At the moment it creates problem, and while it is actually a material that could really be used, no, and then a great advantage of it, unlike many other construction material, it doesn't need any embedded energy in order to become a building material. No, if we think of cement, for example. Cement are extracts from the ground that are fired at 1,200 degrees for many hours to make that material. Earth, no, you can take it from the ground, and if you know how to work with it, you can immediately use it, right? So a material that is local, saving transport, a material that is available, and a material that doesn't consume energy. It sounds like a dream, actually, and it is. Not only in the past, but also today, more and more people start to really look at earth again as a construction material because it was very present. Maybe, reinforced concrete has kind of endangered a little bit its use, no, over time. Earth is not as easy to use as cement for building structures. It's less resistant. It also doesn't resist as well to water and to forces. But from an environment and from an energetical perspective, it's a very interesting material. It works in all continents, and it also works in many different contexts. No? One thing that we really like about it, even if we work with it with very contemporary means of 3D printing, is the fact that earth construction throughout the world exists in also many forms, right? It very often makes techniques that have been developed over, decades, generations, even centuries. So every community in the world that used to build with earth, they have kind of invented their own architecture, their own building mechanisms, their own passive techniques. And so earth construction in the world forms a kind of library of techniques which we really like to look at. They are a bit endangered because there is a stigma when it comes to earth construction. No? It's considered as an architecture for the poor in many parts of the world, and it's being often preferred by concrete block construction, which are not only very little, let's say, efficient when it comes to solar or to heat gain, but also consume a lot of energy. So, as I mentioned before, we are combining this with this new technology of 3D printing. So I mentioned a few times that it's new. It's actually not that new. You know, it's been around for I think since the 70s. A 3D printer. There's someone that woke up here in the next room. Maybe we'll come and say hi later. So a desktop 3D printer, you know, is very affordable today, a small scale. It has a price that is here taken from the internet. So for 300 euros, one can get a 3D printer, and it's also making its way in the construction sector on a much larger scale. The construction world is very interested in 3D printing because it's a robotic technology, right? So, I mean, first of all, it's a technology with which you can build without having any waste. When you pour concrete, you always need formwork. This is a material that is not part of the final outcome. So 3D printing, you only use the material that you need. That is something that is, from an economical point of view, absolutely interesting. And then afterwards, of course, this question of the digital technology means that a lot of work is being done digitally, but it is less labor on site. No? So that's not necessarily something that I'm arguing for, but at least I want to say it because this is one of the reasons why this technology is being looked at a lot in the construction sector, and with this material at the moment is mainly used concrete. From a design point of view and as an architect or as architects, what we are interested in is that, you know, working with this technology enables a certain design freedom, right? And we believe with this technique that we can create, you know, solutions that are potentially unique, no? So solutions that can adapt to the context, to the climate, to the user, and also potentially to the resources that are available in one place. So we are kind of trying to understand what a kind of new architecture could be. Here is a couple of examples from the past. Here we work with a very beautiful Italian company called Wasp 3D that are also printing with earth and that are also developing printers with which we work. So this is our group of students working with their team some years ago, designing a kind of series of steps where you can see an earth wall and then the kind of manipulated geometry that enables to have certain details for steps to go and plug in. No? So a wall can start to include some custom-made detail that can serve, for example, for a step, but also for a window, also for a door. Last year we did this collaboration in Berlin. Actually, that's why I also wanted to have this slide in it with an exhibition that concluded a research project at AEDES in Berlin, and this is something that we did subventioned by the German Ministry of Housing. It's a collaboration between 3 universities and 3 companies, actually. So we work together with CETA, who is a Danish university that in this context brings 3D printing with cellulose, which are these kind of panels that you see with all these curves. We also work with and they work together with Cobot, a 3D printing company from Copenhagen. Then we worked also with ITKE, which is an engineering/architectural design university in Stuttgart that also worked with a startup called Fiber, and they developed these kind of slabs that you see that are hanging over, which are timber slabs that are reinforced with flax fiber, so also a natural material. And then us, together with Wasp, we contributed the 3D printer with earth. No? So this is a kind of exercise in which we were combining different, bio-based material or material that are absolutely non-contaminant to try to understand the interaction and then potentially how they could kind of lead also to living solutions. But in a little bit for this presentation, I like to look at how we are learning from historical examples in order to invent kind of future solutions. So here you have the kind of construction of a dome in Cameroon, actually, and the understanding of this geometry leads us to design many solutions to be able to try to find a very efficient way to make domes or roofs, let's say, with earth. We also look at different ways to support, so to print actually on existing support systems that we look and document ourselves, but also construct with kind of standard, timber profiles, and also looking, for example, at geometries such as the Nubian vault, which is a kind of a very interesting vault system that is antique, actually, that also us, when it comes to 3D printing, help us in order to understand how to get the printer to move, because 3D printing is very close actually to bricklaying, no? So there's a hand knowledge that we really like to look at with this automated technology. And then some speculations that our students do here in the program. I didn't mention, but we are a group that do professional projects, but it's kind of rooted within a master of a 6-month-long master here at the Institute for Advanced Architecture of Catalonia. So a lot of the work that you actually see on the screen is being developed by our students. Another technique that I like a lot, on the left, you can see here an example from Yemeni and Saudi architecture. It's an earth wall, but it is protected by a series of stones that basically make a kind of erosion barrier. So understanding this system and looking at its interpretation with 3D printing, we have in some of our walls kind of created a way to protect earth walls from water erosion. No? That is something that is absolutely important. We look a lot at the inside of the wall, and on the left, it's a building model in Egypt that is made actually of clay pots. So these walls are hollow, and the kind of thermal opportunity of having a hollowed wall is actually quite interesting, depending in different parts of the world in which you are. We've also looked at zeerpots. Zeerpots is a passive fridge from West Africa that is made out of earth. So it's actually working with a kind of double layer. It takes energy from the sun, and it actually creates heat on the outside and coolness on the inside. So you are able to actually lower the temperature by 6 or 7 degrees, which is very good, for example, for the keeping of vegetables, for example, in very hot climates, right? So these are things that we learn, and we've kind of developed a wall here that self-shades itself, right? So the wall has a kind of bumpy texture that is actually derived from the path of the sun to actually have the vertical summer, very harmful sun to create a lot of shadow on the wall, while the winter sun to be very horizontal and to be able to kind of absorb a lot of the heat. No? This is a little bit what this kind of new tools and this new technology and the playfulness enables us to do. And this was kind of happening within the context of a collaboration with UN Habitat, where we were working on the kind of the very difficult scenario of the refugee camp here in Kakuma, where we are thinking about how, rather than importing tents, rather than importing, the building solution itself, like it's very often done, can we rather import the tool and work with a local material in order to produce solutions? Another thing that we really like is actually to use the potential of this 3D printer to make geometries that are potentially complex and let a lot of light in. No? Very often earth architecture is very, let's say, massive, thick walls, very few openings. Because of the use of this robot, we manage little by little to create these walls that have a lot of openings. No? And by understanding a wall that is kind of very hollow, we can also then try to define, a different relationship in terms of privacy, walls that can be seen through, and therefore houses in which, we don't understand simply the wall as a barrier, but the wall potentially as a mediator from one space to another. And in this project that was done by a group of students from Botswana, actually, in the course, to try to think about a contemporary living typology that is not a kind of standardized housing like it is often being done, but actually that learns from vernacular housing models, and to try to kind of bring this into a contemporary context. The last project I want to show is kind of I think our largest achievement so far. It's here in Barcelona in the Collserola Park, where we have a kind of campus. So we have a robot there in the middle of the forest, let's say, and we are excavating directly next to where we build. So a building needs foundation. We kind of make holes for the foundations, and the material that we have excavated we use in order to print the walls. No? So we are, I don't know if kilometer zero is even too long. No, we have to talk about 5 meters. So it's like a very, 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 very small footprint in that sense. So we have this kind of dream of building these big houses, which we think we get there little by little. In this case, we have worked on this project called Tova, where here you see a drone shot of our, let's say, facility there in the forest, where we have the 3D printer. You can see a small space that we're making. It's 3 by 4 meters, and you can see these thick walls, that are very good for thermal behavior, but that are made from the material that comes straight from the ground. Here are some of the details where you can see the construction. On the left, you have this kind of formwork that we use, because the beginning of the kind of first layers of the wall, we like to use dense, thick, and cavity-less material to be able to bear a better contact to water, let's say. But what we do is we do the formwork with 3D printed earth. And as soon as it is cast, we kind of break this formwork, we put it back into the machine, and we print with it. You can see on the right, top right, some ventilation detail that is here being installed by one of our researchers, Dina. On the right, the construction of a big wooden roof that is aimed to protect actually from water contact. And on the left, this kind of beautiful water detail that I mentioned before. So here's a little 1-minute video.
Located at our mountainside campus, the Valdara Labs, in the outskirts of Barcelona, AIAC fabricated the first earthen 3D printed housing prototype of Spain. Given that buildings are responsible for 36% of CO2 emissions, this project is made with fully natural materials to reduce the CO2 impact of construction. The soil is extracted on-site, and the material recipe is optimized with enzymes and fibers for structural and elastic performance when used for 3D printing. From intensive research into the local soil's properties, Tova emerges as a prototype made of durable geopolymers for substructure, composite natural soil mixture for the walls, and a timber structure and joinery details for the roof. The design includes built-in ergonomic 3D printed furnishings and openings that filter daylight. The integrative wall system incorporates passive cavity ventilation and heat conductivity to optimize airflow for cooling and heat insulation, as well as a waterproof coating for the earth. AIAC's ongoing research endeavor showcases the potential of 3D printing on-site construction as a solution to some of the world's existing housing and climate challenges.
And I have one last slide I want to conclude on now. There's a lot, in the architecture field, and I think in many other fields, well, architecture specifically, we're talking about the notion of non-extractive architecture. No? So when you make a building, in order to kind of source the materials, you always end up making a hole somewhere else, no? And very often this hole is not being really addressed, the consequences that it can have on a community, on an environment. This picture here, that has this little explosion of plants in front. Well, the explosion of plant comes from whenever you make a hole in the ground, you kind of go and shake up a kind of system of latent seeds, right? And so, this is why we made the hole to source some of the material. And we came back, a couple of months later, to check how the construction was doing. And we witnessed where we had the wall before, this kind of incredible explosion of greenery. We absolutely didn't anticipate that, but I took the picture from there, and I find it kind of very maybe poetic or maybe subjective a little bit, this last message to say, well, actually, rather than creating holes for the construction that are actually problematic, maybe they can also even kind of somehow add something positive. So I like to finish with that slide. Yeah, that's it. Thank you very much for listening.